So hi everyone, welcome back to a very fresh, very beautiful, fantabulous session of Plus 2 Chemistry. Today we are dealing with the second chapter of Plus 2 Chemistry, that's Electrochemistry. Yeah, it's really a beautiful chapter with not much difficult topics, very beautiful topics. So before starting our class, let me remind you about the disasters that Kerala facing today. So hope all of you have heard about the disasters that the people in Kerala are facing these days, landslides and floods and many more. So if you are willing to contribute something in the form of money or in the form of commodities, please do, and please try to heal them from the pain or loss that they are going through. So we actually, the people from Kerala, I have already mentioned that I'm a person from Kerala, specifically the district Calicut. So the Wayanad district, people from Wayanad district is facing a lot of troubles these days due to heavy rainfall. Hope you all heard about the disasters that they are going through newspapers or social media or any other platform. So if you are willing to contribute something in the form of money or in the form of products like dress, food, everything, please do that and try to heal them. They're going through many problems these days. So yeah. So let's start with today's chapter. The chapter is titled Electrochemistry. So what is the meaning of electrochemistry? What does the word suggest? What does the word electrochemistry suggest? Electrochemistry means what? Means what? It's already there in the word electro and chemistry. What is it, man? Yeah, it's a relationship between electricity and chemical changes or chemical reactions. So electrochemistry is a branch of chemistry which deals with the relationship between electrical energy and chemical energy. As the word suggests, okay, electrochemistry is a relationship between electrical energy and chemical energy. Okay, it's a branch of chemistry, deals with interrelationship between electrical changes and chemical changes. So what can we do in electrochemistry, or what are we studying about in the field of electrochemistry? We are studying about the changes that's happening in a chemical setup which will initiate electricity, or a chemical change that is undertaken using electricity. All those stuffs has been studied in this chapter, electrochemistry, or the branch of electrochemistry, the branch of chemistry which is electrochemistry. So you know what is electrochemistry, right? It's a branch of chemistry dealing with the relationship between electricity and chemical changes, or electrical energy and chemical energy. So what's that called? What's the process called? The process of converting electrical energy to chemical energy, or the process of converting chemical energy to electrical energy. What's the process called? The process is called electrolysis. Electrolysis, chemical reaction due to passage of electricity, or we are undertaking chemical reactions to produce electrical energy. So either way, from electricity to chemical changes or chemical changes to electricity, that process, the conversion, the process of converting electrical energy to chemical energy, or the process of converting chemical energy to electrical energy is called what? Electrolysis. Hope it's clear to you. So electrochemistry is a branch of chemistry dealing with the interrelationship between electrical and chemical energies, and electrolysis is a process of the interconversion between those energies. Now, what is electrochemical reaction? So before saying about the electrochemical reaction, we need to know what a cell is. We need to know what a cell is. Cell. Cell means it's a device which is used to convert electrical energy to chemical energy, or chemical energy to electrical energy. So for example, I use WhatsApp, I use Facebook, I use Instagram, I use YouTube. So in order to use all those applications, I need a device, and the device is my mobile phone or my laptop or my computer. So such a way, so as to perform electrolysis, which is based on the branch of chemistry titled electrochemistry, I need a device. I need a device similar to my phone. In the case of phone, I'm using WhatsApp, Facebook, Instagram, everything. Similar way, so as to perform electrolysis here, I need a device, and that device is called a cell, and the device is called a cell. This cell is of two types. Which are the two types? Electrolytic cell and electrochemical cell. Electrolytic cell and electrochemical cell. So we already know that the process of electrolysis means the process of interconversion between electrical energy and chemical energy. Okay, this way or that way. So tell me, in the electrochemical cell, which conversion is possible from electrical energy to chemical energy or chemical energy to electrical energy? Which conversion is possible in electrochemical cell? In the beginning of the class, I told you, check the title of the chapter. It's electrochemistry. Then what does the word suggest? As per electrochemistry, check the word electrochemistry. Yeah, I repeated the same thing, right? Similar way, check the word. Check the word here. It's electrochemical cell. So what type of conversion will be possible here? Either electric energy to chemical energy or chemical energy to electrical energy will be performed by electrochemical cell. Which will be performed? As per the word, electrical energy is converted to chemical energy as per the word, right? But it's not happening here. Actually, chemical energy is converted to electrical energy in the case of electrochemical cell. So please keep that in mind. In the case of electrochemical cell, chemical energy is converted to electrical energy. And what about the case electrolytic cell? What about the case of electrolytic cell? What type of conversion is happening in electrolytic cell? Yeah, the vice versa of what's happening in electrochemical cell, right? In electrochemical cell, chemical energy is converted to electric energy. So in electrolytic cell, electrical energy is converted to chemical energy. Simple. So you know what a cell is. It's a device to convert electrical energy to chemical energy or chemical energy to electrical energy. So for that purpose, I have two cells in my hand. That is, one is electrolytic cell and the other is electrochemical cell. In the case of electrochemical cell, I can use it for converting chemical energy to electrical energy. I can use electrolytic cell to convert electrical energy to chemical energy. Now, tell me what's electrochemical reaction? Tell me what's electrochemical reaction? Yeah, it's a reaction taking place in electrochemical cells. So what is it doing? Electrochemical reaction means it's converting chemical energy to electrical energy. The process of converting chemical energy to electrical energy in an electrochemical cell is called electrochemical reaction. Okay, so electrochemical cell is performing electrochemical reaction, which is the reaction of converting chemical energy to electrical energy, and the electrochemical cell can also be called as galvanic or voltaic cell. This electrochemical cell can also be called as a galvanic or a voltaic cell. Fine. So in this chapter, we are going to deal with electrochemical cell in the first half of the session. So let us proceed with the chapter. So this is an electrochemical cell. More specifically, this is a Daniell cell. Okay, Daniell cell. If I go to a store, okay, I need mobile, for sure I need mobile. So consider mobile as an electrochemical cell. Okay, but there are different brands of mobile available in the shop. For example, Samsung, iPhone or Oppo, Vivo. Okay, there are many brands available in the store. Okay, so the phone as in whole is an electrochemical cell or a galvanic cell or a voltaic cell. But more specifically, I need Oppo's phone, or I need an iPhone, or I need Vivo's phone. So such a specification is called Daniell cell. Means Daniell cell is simply an example of electrochemical cell or galvanic cell or voltaic cell. Okay, Daniell cell is a galvanic cell, or it's a voltaic cell, or it's a electrochemical cell. Or more specifically, we can say that Daniell cell is an example of electrochemical cell. Similar to that, Vivo is an example of mobile brands. Oppo is an example of mobile brands. Similarly, Daniell cell is an example of electrochemical cells or galvanic cells or voltaic cells. So, shall I specify the name here? Daniell cell. This is a very important topic in electrochemistry that from which many questions can be expected. Okay, so you need to know this apparatus, you need to know its functioning, You need to know the cell reactions, you need to know the cell representations, and many other things have to be studying from this single topic. So shall we start with the apparatus and its working? Alright, so consider two beakers. I have two beakers in my hands. In one beaker, I am dipping zinc rod. In the other beaker, I am dipping copper rod. Okay, so zinc rod is dipped in zinc sulfate solution. Zinc rod is dipped in zinc sulfate solution. Copper rod is dipped in copper sulfate solution. Why did I choose zinc sulfate and copper sulfate for zinc and copper respectively? Is there any specific reason for that? Yes, there is a specific reason for that, because if you're dipping a metal in an electrolyte, if you're dipping a metal in an electrolyte, make sure that the electrolyte has ions similar to that of metal. As zinc sulfate has ions similar to that of zinc, I'm dipping zinc in zinc sulfate solution. As copper sulfate has ions similar to that of copper, I'm dipping copper in copper sulfate solution. So see, copper sulfate is actually Cu2++ SO4 2-, right? So copper sulfate solution has ions similar to that of copper, that is Cu2+. In zinc sulfate solution, similarly, Zn2+ and SO4 2-, right? Zn2+ is there, ion similar to that of the metal dipped in the electrolyte. So make sure that whenever you are dipping a metal in an electrolyte, the ion similar to that of metal should be present in the electrolyte. Otherwise, the circuit will not work. If you are dipping zinc in copper sulfate or copper in zinc sulfate, the circuit is incomplete. Hope it's clear. So now, hope the anode and anodic solutions are clear. Anode is zinc, cathode is copper, and anodic solution is zinc sulfate here, cathodic solution is copper sulfate here. I am connecting this anode and cathode, that is zinc and copper, using a conducting wire. I'm also placing a voltmeter here to detect the presence of current. Okay, this is a galvanic cell, right? So electricity has to be produced from chemical reaction. So we need to know whether electricity is produced or current is produced there. So for that we need a voltmeter, or else you can keep a bulb so as to detect the presence of electricity. So whenever current flows through it, voltmeter deflects, right? Voltmeter needle deflects. Or if you keep a bulb will glow whenever current is passed through it. So you can keep anything which is whichever possible for you, but we need to know whether current is flowing. So for that I kept voltmeter here, and also I have connected these two solutions using salt bridge. In later session, towards the end of this part, I will discuss what is salt bridge, its function, and what all are used to prepare salt bridge. So here, this is apparatus, metal zinc dipped in zinc sulfate, copper dipped in copper sulfate, and it's connected using conducting wires, and a voltmeter space placed there. Salt bridge is also placed there, connecting these two solutions. Now, I'm taking zinc as anode and copper as cathode. Why did I do that? Before coming to the answer of that question, tell me, electricity is produced here, current is produced here. Due to what type of reaction current is produced here? What type of reaction is happening in Daniell cell which is capable of producing current, or which is responsible of producing current, What type of reaction? You have studied this reaction. The name of this reaction is very, very, very familiar to you, because you have studied it in +1, 10th, maybe, yeah. So tell me, what type of reaction is happening in this redox? I said the name right. Okay, redox reaction is happening here. Oh my god. Redox reaction is happening in Daniell cell, which is responsible for the production of current, which is responsible for the production of electricity. Redox reaction. What is redox reaction? Reduction and oxidation is taking simultaneously. Such a reaction is called redox reaction. So tell me, in which part of this Daniell cell reduction is taking place and which part is responsible for the oxidation? You already know that redox reaction is the reason for production of current here. And I've already asked you a question this is anode, this is anode. Why this is cathode? Why have chosen zinc as anode and copper as cathode? So for that, for the answer, for you to reach the answer of that question, you need to know in which electrode reduction is taking place and in which electrode oxidation is taking place. So here zinc is undergoing oxidation. Zinc is undergoing oxidation and copper is undergoing reduction. Hope you know what is oxidation and reduction. Oxidation means removal of electrons from a species, and reduction means accepting electrons. If I am donating electrons to you, okay, I am getting oxidized. If you are receiving the electrons which I have given you, you are getting reduced. So here in the case of Daniell cell, zinc is getting oxidized, copper is getting reduced, means zinc is giving electrons off to copper and copper is accepting those electrons given by zinc. So shall we see the reduction equation and oxidation equation of zinc and copper? So as I already said, zinc is getting oxidized. So zinc must give electrons, right? So zinc becomes zinc 2 plus by giving 2 electrons. Zinc becomes zinc 2 plus by giving 2 electrons. This 2 electrons travel this way and reach the cathode area. Here in the case of copper, copper gets reduced by accepting 2 electrons and becomes Cu, copper. Okay, so the electrons given by zinc, that is 2 electrons, gets deposited on the cathode or it is received by copper. Okay, how did Cu2 plus come? How did Cu2 plus come? CuSO4 has Cu2 plus and SO4 2 minus. This Cu2 plus gets combined with 2 electron minus 2 electrons given by zinc and gets reduced to Cu. Okay, so that's the reduction reaction and this is the oxidation reaction. Oxidation reaction and reduction reaction of Daniell cell. Okay, hope that's clear. So we need to know the overall reaction. So the oxidation reaction is like this. Zinc gives zinc 2 plus 2 electrons minus, and in the reduction area copper 2 plus 2 electrons minus gives copper. So we have already learned how to write an overall cell reaction, in your previous classes. Just delete these 2 electrons and you'll get zinc plus copper 2 plus gives zinc 2 plus copper. This is the overall cell reaction of Daniell cell. Now, I've already told you this is anode and this is cathode, right? Oxidation is taking place in anode, reduction is taking place in cathode. So now let me tell you, LOAN. This is a code that you can keep in mind always, because L for left, A for anode. So left side, in the left side there will always be anode. And anode undergoes oxidation, which is represented here by the letter O, and N for negative. Anode has got a charge, negative charge. Anode has got negative charge. So lone, the word lone means what? Lone means nothing but left, oxidation, anode, negative. Left side you will see anode, and anode is undergoing oxidation, and anode is always negative. Hope that's clear. Now, we have already discussed this galvanic cell performs redox reaction, which is responsible for the production of current in galvanic cell or Daniell cell. Oxidation occurs at anode and reduction occurs at cathode, and this is the reduction half reaction and oxidation reaction. Reduction half reaction means the overall reaction is a combined form of half reactions of oxidation and reduction. Now coming to half cells. What is a half cell? In the case of Daniell cell. In the case of Daniell cell, we have two beakers. We are dipping an electrode here. Two electrodes. One is anode, other is cathode, connected by voltmeter and a salt bridge. Right? So here half cell means half of the cell, that's all. Either oxidation anode cell or the cathode cell. Half cell, oxidation half cell and reduction half cell. So this is my overall body, the whole body of mine, right? If I divide it into two, this will be my right half body and left half body. Similarly, in the case of Daniell cell, this is the anode half cell and this is the cathode half cell, or this can be more specifically said as oxidation half cell, and this is this side is the reduction half cell. Oxidation half cell and reduction half cell. Hope the concept of half cell is clear to you. Next is potential difference between electrodes, which is termed as electrode potential. So here, this is an electrode, right? This is an electrode. Here, I'm having an electrolyte. So the electrode is dipped in an electrolyte having ion similar to that of the electrode, right? So this electrode is dipped in this electrolyte and there exists a potential difference between the electrode and electrolyte. There exists a potential difference between the electrode and electrolyte. That potential difference, or the potential between electrode and electrolyte, or its electrolyte, is called electrode potential. What is electrode potential? You will be asked for 1 mark or 2 marks. Define electrode potential. So you need to or you should be able to define what electrode potential is. Electrode potential is a potential difference between the electrode and electrolytic solution. Hope it's clear. Now coming to standard electrode potential. What is standard electrode potential? It's similar to that of electrode potential, but what's the only difference? The electrode potential at standard conditions is standard electrode potential. Electrode potential at standard conditions is electrode potential. Standard electrode potential. What is standard condition? At standard temperature and pressure. Standard temperature and pressure, where the concentration of electrolyte used is 1 molar, you'll get the standard electrode potential. Standard electrode potential. Okay, the electrode potential is represented as E cell. Standard electrode potential is represented as nothing but E naught cell. Okay, means the electrode potential at standard conditions. What are the standard conditions? STP, standard temperature and pressure condition, where concentration of the electrolyte is 1 molar. In such a condition, the electrode potential is called standard electrode potential. Now EMF of the cell. EMF of the cell is nothing but it's a difference between the potentials of electrodes. Okay, it's EMF of the cell is represented as E cell, or the electrode potential of the cell, or the cell potential. EMF is more specifically the cell potential. The cell potential is equal to E cathode, that is cathode potential, minus anode potential. Cathode potential minus anode potential. So the cell potential is the difference between cathode potential and anode potential, or it's a difference between the potential differences. It's a difference between the potentials of cathode and anode. All right. So EMF of the cell, E cathode minus E anode, or it's a reduction potential of cathode minus reduction potential of anode. You know what is reduction potential and oxidation potential, right? Reduction potential means the potential of the electrode accepting electrons, or the potential where reduction is taking place, right? Oxidation potential is a potential of the position where oxidation is taking place. So reduction potential of cathode minus reduction potential of anode will give you the overall cell potential, or simply just the cell potential is the difference between cathode potential and anode potential. All right, E cathode minus E anode. What about the cell potential or EMF in standard condition? Standard condition is just E naught cell equal to E naught cathode minus E naught anode. All right, then coming to the salt bridge functions. Salt bridge. I've already told you that before, while taking the apparatus, while talking about the apparatus of Daniell cell, that I'll be explaining salt bridge later, right? Later session of this class. So salt bridge is actually two beakers, two electrodes connected by a voltmeter or bulb, and a salt bridge here, salt bridge, right? The salt bridge is actually made up of inert electrolytes along with gel-like substances like agar-agar gel, gelatin, etc. Because inert electrolytes have a tendency to flow, and they may fall into this electrolyte solution and disturb the system. So as to avoid such a problem, we use agar-agar gel or gelatin with inert electrolytes. Okay, so salt bridge is made up of what? Agar-agar gel and gelatin, or gelatin along with inert electrolytes like KCl, NH4Cl, etc. Agar-agar gel or gelatin. Fine. So what is a salt bridge? Salt bridge. What is the shape of a salt bridge? It's an inverted U-tube. Is it YouTube that you're watching videos or the classes of DNA learning? No, not that. Okay, inverted U-tube, because the shape of the salt bridge is that of U, inverted U-tube. So salt bridge consists of glass U-tube or inverted U-tube. So what are the functions of salt bridge? What are the functions of salt bridge? Salt bridge is present in a Daniell cell or a galvanic cell so as to isolate the anodic solution and cathodic solution. Also, the salt bridge is present there not to interfere with this overall cell reaction, okay, overall cell processes. Shall we go to the functions of salt bridge now? Given here, not to interact chemically with either of the solutions present in anodic or cathodic chamber. Okay, salt bridge is present in a galvanic cell or a voltaic cell so as to isolate the anodic and cathodic solution, because not to allow them to interact chemically with each other. Also not to interfere with overall cell reaction. Salt bridge is present there. Now, representation of galvanic cell. You are already familiar with the molecular formulas, right? Molecular formula of methane, CH4, water, H2O, ammonium chloride, NH4Cl, carbon dioxide, CO2. So this is actually a representation of the molecules, right? CO2, carbon dioxide is represented as CO2, ammonium chloride is represented as NH4Cl, water is represented as H2O, CH4 means the representation of methane, right? So all these molecules are represented in this format. Why not? We can represent the Daniell cell or the galvanic cell or the voltaic cell. We can also represent those cells. How are we going to represent those cells? We are going to study that in detail here. Now, representation of galvanic cell. So first of all, you need to write the anode. The slash is not right here, so I'll write on board. First of all, so as to represent a galvanic cell, you need to write the anode. Then draw a line, a straight line, anode. Next comes the anodic solution or the electrolyte in which the anode is dipped. And next comes two lines, and cathodic solution. Cathodic solution is the solution in which cathode is dipped. One line and cathode. This is the representation of a cell representation. Anode, anodic solution, two lines, cathodic solution and cathode. So what does these two lines signify? Two lines. We just discussed about it. These two lines. An important part of Daniell cell. What is it? Salt bridge, exactly. This is salt bridge. Okay, So first of all, you need to write the anode separated by a line. Anodic solution, you need to write the anodic solution next. Draw 2 lines so as to signify salt bridge. Then cathodic solution, 1 line and cathode. This is the general way to represent a cell like galvanic cell or voltaic cell. Now representation of Daniell cell. Shall we try representing Daniell cell similar way? Yeah, let's try. So in the case of Daniell cell, the anode, first of all, we need to write the anode and anodic solution, salt bridge, cathodic solution, then comes cathode. So in the case of Daniell cell, what is the anode? Anode is zinc. What about the solution, anodic solution? Anodic solution is zinc 2+. Why did I use zinc 2+ here? Why not ZnSO4? ZnSO4 is actually what? I've already told. ZnSO4 means Zn2+ plus SO4 2-. Avoid SO4 2- and just Zn2+, because we are requiring an electrolyte or anodic solution having the same ions. So just ignore SO4 2- and write Zn2+. Then salt bridge, cathodic solution. What is a cathodic solution used in a Daniell cell? Copper sulfide solution. So just write copper 2+, no need of SO4 2- and draw a line copper. Okay. So keep this in mind. This is the general cell representation of Daniell cell. Zinc, Zn2+, and separate by salt bridge, copper 2+ and copper. Okay. Now, what if silver electrode acts as the cathode and copper electrode acts as an anode? So it's already given in the question, what is anode and what is cathode? So anode is copper, and cathode is silver. So first of all, write the anode, that is copper here. And in the copper sulfate solution, we should write only the Cu2+ section. Separated by a salt bridge, we have silver here as the cathode. Silver will be dipped in silver sulfate solution, AgSO4 solution. So here Ag+ is the only essential component. Then write the metal, the cathode. Anode, anodic solution, cathode, cathodic solution and cathode. For example, if this is not specified in the question, what if silver electrode and copper electrode are used in a Daniell cell or galvanic cell? Write the cell representation. You're not specified which is the cathode and which is the anode. How will you write? How will you determine whether which is the cathode or which is the anode? Whether silver is a cathode or anode, how will you determine that? So for that, you need to know one thing, which is having high reactivity. In the case of copper and silver, copper is having high reactivity, hence copper is selected as anode. Or the one which is having tendency to remove electrons. Okay, copper is having high tendency to remove electrons than Ag. Ag is having tendency to accept electrons. So on the basis of that, you need to find which is anode and which is cathode, or based on the reactivity. In the case of Daniell cell having zinc and copper, a reaction like this, zinc plus copper sulfate, gives what? Zinc is capable enough to displace Cu from CuSO4 solution. So zinc is having high reactivity. So the product will be zinc sulfate plus copper. Alright. Zinc is having high reactivity and it's capable enough to displace Cu from CuSO4 solution. So the product will be zinc sulfate and copper. Similar way, if you are provided with two components like silver and copper, or copper and zinc, or any other components, you need to know which is high reactive or which is having the higher tendency to oxidize. Okay, such a species will be the anode, will be chosen for anode. Now we are having another topic, She standard hydrogen electrode. So this topic will be discussed in the later session, that is a part 2 of electrochemistry of class 12. So before that, you need to learn this part 1, you need to learn all the topics discussed in part 1. Yeah, okay, till the next class, bye.